Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. An insurance company has an equal number of claims in each of 3 territories. In each territory, only 3 claim amounts are possible: 100, 500, and 1000. Based on the company's data, the probabilities of each claim amount are: in territory 1, 0.90 for 100, 0.08 for 100, 0.08 for 500, and 0.02 for 1000. In territory 2, 0.8 probability for a claim of 100, 0.11 for 500, and 0.09 for a claim of 1000. In territory 3, 0.7 probability for a claim of 100, 0.20 probability for a claim of 500, and 0.10 probability for a claim of 1000. Calculate the standard deviation of a randomly selected claim amount. Well, let's write x for the overall random claim amount and x1, x2, and x3 for the random claim amounts in territories 1, 2, and 3. Then, because the numbers of claims are evenly distributed in all of those 3 territories, what we have is that x is a mixed distribution with x equal to xi for I equal to 1 to 3 with probability 1/3. And therefore E of x is 1/3 of E of x1 plus 1/3 of E of x2 plus 1/3 of E of x3, and we just calculate that. So 1/3 times 0.9 times 100 plus 0.08 times 500 plus 0.02 times 1000 plus 1/3 times 0.8 times 100 plus 0.11 times 500 plus 0.09 times 1000. That was for the second territory, and for territory 3 plus 1/3 times 0.70 times 100 plus 0.2 times 500 plus 0.1 times 1000. And this is equal to 1/3 times 150 plus 1/3 times 225 plus 1/3 times 270. And so the overall mean is equal to 215. For the second moment, we do the same calculation. E of x squared is equal to 1/3 of E of x1 squared plus 1/3 of E of x2 squared plus 1/3 of E of x3 squared. And of course you know that because that's the standard approach for any moment of a mixed distribution. And one of the points of this problem is to remind you that the variance of a mixed distribution is not a weighted average of variances of individual pieces of that mixed distribution. The moments are. So the first moment, second moment, third moment, and so on. And that's what we do. This is 1/3 times 0.9 times 100 squared plus 0.08 times 500 squared plus 0.02 times 1000 squared for territory 1 plus 1/3 times 0.8 times 100 squared plus 0.11 times 500 squared plus 0.09 times 1000 squared for territory 2 plus 1/3 times 0.70 times 100 squared plus 0.2 times 500 squared plus 0.1 times 1000 squared for territory 3. And this is equal to 1/3 times 49,000 plus 1/3 times 125,500 plus 1/3 times 157,000. And so the overall second mean is equal second moment, not second mean, is equal to 110,500. And the variance is the second moment minus the square of the first moment, so 110,500 minus 215 squared. I had 212 there. I'm very sorry. So I just corrected this typo. So it's 110,500 minus 215 squared. And that's equal to 64,275. And the standard deviation of x is the square root of its variance. and that's approximately, with the square root of 64,275, that's approximately equal to 253.53, and that's answer A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.